All right, we are starting Unit 2, and in Unit 2 we're going to study transformations. Transformations is something that you guys should have studied probably in middle school as well as Algebra 1. So it's something that we have some background knowledge on. In this class, we're primarily talking about transformations in a coordinate plane. So before we get started in transformations, I want to make sure we remember some things about the coordinate plane. So let's take a look at the warm-up. You should have completed this on your own. This is just a way to check your answers, or if you got stuck, a way to get help. I want you to label the x and y axis. I know the x-axis is my horizontal axis, so this would be my x-axis. My y-axis is my vertical axis, so we can label that there. Next part says graph the line and label it with the equation. So I'll go ahead and do these in different colors. If we have y equals x, I'm looking at that and I can think of slope-intercept form. Y equals mx plus b, where m is my slope, where the coefficient of x is the slope, b is the y-intercept. And so when I look at this equation y equals x, I know that my slope, I can't see it, so the coefficient of x must be 1. And then my y-intercept, I don't see that I'm adding anything, so I must be adding 0. So I can plot the y-intercept of 0, my slope of 1, rise 1, run 1, and plot these points. So I have an increasing function. I could also go down 1 and to the left 1 to extend this the entire way through the coordinate plane that is depicted. I'm going to connect these with this nice straight line, and I will label this with the equation y equals x. It also asks us to graph the next equation, y equals negative x, which has the same y-intercept, we still have a plus 0, but that negative in front means the slope is negative 1, so this will be a decreasing function. So I plot my y-intercept of 0, 0. I go down 1 and to the right 1. And now I can see that I have a decreasing function because y-intercept is 0. I could also go up 1 to the left 1 to graph the other part of the line in the coordinate plane. And again, I'll connect these with a nice straight line and label this y equals negative x. The next line, I look at this equation. I don't see an x anywhere. I just see y equals. If I'm thinking y equals mx plus b, I could think of this as y equals 0x plus 5, because 0 times x is 0, and 0 plus 5 is 5, which means that my y-intercept is 5, and my slope is 0, which means I'm not increasing or decreasing. So I'm not rising or running anything. This ends up being a horizontal line. In other words, it's all the points whose y-coordinate is 5. So we have a horizontal line connecting all of the points whose y-coordinate is 5. This right here, we will label y equals 5. In this last equation, we have x equals negative 4. With x equals negative 4, I don't see a y. This is not in slope-intercept form. If you had to pick a form, you would call this standard form, because we don't have a y equals. And when we see x equals negative 4, we can think of this as, we're just making a table, your x and your y. It means x is always negative 4. It doesn't matter what y is. We could have 0, 1, 2, makes no difference. If I plot these, negative 4, comma 0, negative 4, comma 1, and so on. And if we extended that table, we would see that we'd end up having a vertical line. So this is not a function, because the input of negative 4 has an infinite number of outputs. This is just a vertical line, x equals negative 4. So those are all of our graphs. Number 3 wants us to know the difference between y-coordinate, y-intercept, and y-axis. I'm not going to write these in complete sentences. I'm just going to talk through them. The y-coordinate, when we talk about y-coordinate, we're talking about an ordered pair. So for example, if I had the point 6, comma 2, 6, comma 2 has an x-coordinate and a y-coordinate. The y-coordinate would be the second coordinate in an ordered pair. So when I say y-coordinate, it means the second number in an ordered pair, or a point. Y-intercept is referring to something different. The y-intercept is talking about where the graph intercepts the y-axis. So in that case, for the line y equals 5, the y-intercept would be 0, comma 5. for this line, y equals x, or y equals negative x, the y-intercept is 0, 0. So it's wherever the graph or function or relationship, whatever we're talking about, crosses the y-axis. Notice that this vertical line here, x equals negative 4, does not have a y-intercept. And finally, the y-axis in a coordinate plane is this axis right here, the vertical axis. And so we need to understand what the y-axis is in order to understand the y-intercept. And I want to make sure we know the difference between those three vocabulary terms. That's just a real quick review of some algebra. I want to make sure we understand that so when we have conversations about the coordinate plane, we're good to go. Now I want to have a quick introduction about transformations. You've studied transformations in the past. If you think about transformations that you've studied in the past, it's essentially talking about if I have, for example, my cell phone here, what can I do to transform my cell phone? Okay, so I can do a couple things. I can spin it around, and if I spin something, that is called a rotation. I can also flip it. Flipping it would be reflecting it. I can translate it, which is just sliding it, and I can translate it in any direction I want. And then there's also another transformation that I can't do with this cell phone right here, but in Algebra 1 we talked about stretching or shrinking something. Now you only talked about vertical stretching and shrinking in Algebra 1. In Algebra 2 and pre-calc you'll start getting into horizontal stretching and shrinking. And what that means is vertically, up and down, we can stretch something, make it skinnier, or shrink something, make it wider. And in Algebra 2 or pre-calc, when you talk about horizontal stretching and shrinking, it means if I have this guy and I'm stretching it horizontally, it gets wider. If I shrink it horizontally, it gets more narrow here, smushes everything in. So let's talk about this in a little more detail. If you had the parent function of quadratic functions, so think back to quadratic functions, parent function would be y equals x squared. If I graph that, I would get 2, 3, 9. If I square 1, negative 2, there we go. This is the parent function of quadratic functions. Y equals x squared. In your previous math course, we studied a couple transformations with this. We studied translations. We can translate in any direction, up, down, left, or right. We studied a reflection. In your Algebra 1 class, I believe you only did reflections in the x-axis. We're going to do reflections in other lines as well. And then you did vertical stretching and shrinking, and I'm going to put that down here for a reason. Vertical stretching and shrinking. So that's what you talked about in algebra. What we're going to talk about in geometry is what you talked about in previous courses as well. You did talk about rotations at some point, whether that's elementary school, middle school, wherever you were. So there were rotations. So these three we're going to talk about. We're going to use the same terminology. We're not going to use the terminology vertical stretch or shrink. In this class, we're going to talk about something different. When you stretch or shrink something, or enlarge or reduce it, we're going to call that a dilation. So I'm going to cross this out. We're going to say dilation. Okay? So we have 4 different transformations that we are going to study, all of which I believe you have some background knowledge on. What I want to talk about right now is this word isometry. The definition of an isometry is that an isometry is a transformation that preserves, another word for preserves is keeps, doesn't change, length and angle measure. Preserves length and angle measure, meaning after I perform the transformation, the length of the object and the angle measures that are within the object do not change. So I'm going to underline isometry. Based on your knowledge, circle the different transformations that you think are isometries, just based on what you were thinking before. We're going to explore this a little further to determine with certainty whether these different transformations are isometries, but I wanted you to keep in mind just a prediction of what you think would be an isometry or not, but we're going to talk at length about that later. So let's go back to this quadratic function here, this parent function. In Algebra 1, again, you talked about translating that. So if I were to translate this right, let's say 5 units. So translate right 5 units. I would take each point and translate it right 5 units. So I take the vertex 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And if I keep doing this, I will see 1, 2, 3. I can connect these points again, and here's my graph translated 5 units to the right. Okay. In Algebra 1, you should be able to come up with that equation. If you would like to try and come up with that equation, pause the video now, and then we can test our answers here. So try and come up with the equation for this function if you think you remember how to do that. All right, to test your knowledge, we have the equation would be y equals, to translate to the right 5, we do x minus 5 in parentheses squared. So that would be my equation. Not something you have to know right now in geometry, but something good to recall. One thing I do want to talk about is a little bit more vocabulary and some notation stuff. When we talk about these different shape and then doing a transformation to it, there is some vocab that is important. So if you have this point here and we label this point A, let's label this. If we label that A, then its corresponding point after a transformation has occurred, we will denote using A prime. So it's a little apostrophe or a little accent mark, however you want to look at it, and that is called prime. So this is point A, this is point A prime. So A prime is the image of, and I'll use colors here, of A. And we'll say after the transformation. So if you transform point A, you're going to have the corresponding point A prime. There's also a term called preimage. So we will say that A is the preimage of A prime. So if I ever give you what the coordinates of a point are after, we could talk about the point, corresponding point that we would do before that transformation, and that's called the preimage. So just a little vocab terms, a little refresher on transformations before we dig into actually performing transformations in a coordinate plane. The next video will be about translations.